by Clay Winter. Introduction. Gravity, the force that governs the motion and behavior of celestial bodies, has long intrigued scientists and philosophers alike. While our understanding of gravity has evolved through centuries of observation and study, the exact origin of this force has remained a subject of ongoing investigation. This paper aims to explore the hypothesis that gravity is a force derived from the spin and size of an object within space, drawing a parallel to the concept of static electricity's pull. The basics of gravity. Gravity, as described by Isaac Newton in his law of universal gravitation, states that every mass attracts every other mass with a force proportional to the product of their masses and inversely proportional to the square of the distance between them. Newton's theory of gravitation provided a fundamental framework for understanding gravity, but subsequent theories, such as Albert Einstein's general theory of relativity, offered a deeper understanding of this phenomenon. The spin-gravity hypothesis. According to the hypothesis being explored in this paper, the spin and size of an object within space may contribute to the generation of the gravitational force. This concept draws inspiration from the nature of static electricity, which results from the transfer of charges between objects, leading to an attractive or repulsive force. Size and gravity. The first aspect of the hypothesis suggests that the size or mass of an object influences the strength of its gravitational pull. In the realm of static electricity, larger objects tend to accumulate more charge, resulting in a greater attraction or repulsion. Similarly, in this hypothesis, a larger celestial body would possess a higher gravitational pull. Spin and gravity. The second aspect of the hypothesis focuses on the spin, or rotation, of an object and its relation to gravity. Just as charged particles' motion generates electric currents, the rotation of an object could potentially generate a gravitational field. As the object spins, its gravitational field may be affected, leading to alterations in its gravitational pull. Thus, an object's spin may contribute to the direction and intensity of its gravitational force. Explaining Newtonian gravity. The connection between the spin and size of an object and its gravitational force can be seen within Newtonian gravity. When two objects are in proximity, their gravitational interaction is influenced by factors such as their sizes and distances. While Newton's laws did not explicitly incorporate spin, the hypothesis suggests that the variables associated with an object's spin would contribute to the gravitational force experienced by nearby masses. Limitations and ongoing research. It is important to note that the spin and size of an object alone cannot fully explain the complex nature of gravity. The hypothesis presented here is a speculative idea aimed at broadening our perspective on this fundamental force. To date, scientific exploration has not established a direct causal relationship between spin, size, and gravity. Further research, experimentation, and theoretical developments are required to validate or refute this hypothesis. Conclusion. Gravity remains a captivating topic of study, and numerous theories attempt to explain its origin and mechanisms. The hypothesis proposing that gravity is influenced by the spin and size of an object within space, akin to the pull of static electricity, offers a fresh perspective to explore this force. While still speculative, this hypothesis opens up avenues for further research and invites scientists to examine the intricate relationship between gravity and the properties of celestial bodies in greater detail.